Welcome to this online revision session for AQA M2, in which we were looking at the June 2011 question 3 on the topic of kinematics using vectors. You can see we are given a particle moving in a horizontal plane, and it's being acted on by a force F, and its velocity at any time is given by this expression here, 4e to the minus 2ti plus 6 minus 3tj, where I and j are our base vectors, I in the direction east, along the x-axis effectively, and j along in the direction north, along the y-axis effectively. First part says find an expression for the acceleration at time t. So the key thing we need to do there is to remember that the acceleration is the differential of the velocity, and that when we differentiate vectors we differentiate the separate components, and so we have to differentiate the 4e to the minus 2t. Well, we should know the differential of e to the something is e to the something, but then we got to differentiate the minus 2t, which is minus 2, so we end up with negative 8, that's the minus 2 times the 4, e to the minus 2ti, and then we have to differentiate the second part, so the differential of 6t is 6, and the differential of the 3t squared is minus 6t, and that's multiplied by j. So there is our expression. We get 3 marks for that particular part. So our 3 marks will be from 1, using an appropriate method, attempting the differentiation in other words, and then one answer mark for the I part being correct and 1 answer mark for the j part being correct. Then it says that there is a mass of 5 kilograms. We'll find an expression for the force acting on at time t. So we know that force is mass times acceleration, and so we need to multiply our acceleration by the mass of 5 kilograms, so we get minus 40 e to the minus 2ti plus the j part multiplied by 5, which will give us 30 minus 30t. What's a j? So again, a method mark for realising you've got to multiply the mass times the acceleration, and then an accuracy mark for getting the correct expression there. Next part, part 2, then says find the magnitude of f when t equals 0. So we can say that when t equals 0, f will equal, so if we substitute 0 in, e to the 0 is 1, so we get minus 40j, and then we get 30 minus nothing, so that's just plus 30 plus a j. Sorry, didn't I say j when I meant I there, didn't I? Apologies. So it's minus 40i plus 30j. Now that's the force itself, so now we want the magnitude of that force. Parallel lines means magnitude, or we could just do a letter F with not being underlined as a vector. And so what we have to do is to take each part, so it's minus 40 squared plus 30 squared, that's the j component, and then we have to square root that answer, But we really don't have to do any working at all, because we should realise it's a 3, 4, 5 triangle, so the answer is 50 newtons. Again, 2 marks there. 1 for obtaining the appropriate expression here for this square root there, so there'll be a method mark for that, and an accuracy mark for obtaining the correct value for the magnitude. Part C then says find the value of t when F is acting due west. So if it's acting west, then that means that there is no vertical component. So the j component must be 0. So we need to state that j component is 0, which implies, of course, that 30 minus 30t must equal 0, and so t must equal 1. So again, 2 marks for that, so it's a method mark for realising that the j component has to be 0, and then a mark for getting the correct value of t. Finally, on to part D of the question. We're told that when t is 0, the position of the particle is 6i plus 5j. We have to find the general position vector for r at time t. So this time we're trying to find the displacement vector r. So we need to realise that to get back to the displacement, we have to integrate the velocity vector. So we've got to integrate 4e to the minus 2ti plus 6t minus 3t squared j. And if you remember that to integrate, just like when we differentiate, we do the integration to the separate components. So the integral of e to the minus 2t, well, it's an e function, so it's e to the minus 2t, but then the differential of the minus 2t is negative 2, so we've got to divide by the negative 2, so we get minus 2 in front. That's 4 divided by negative 2, plus some constant, c1, lots of I. And similarly, we integrate the 6t, we will get t squared over 2, so that gives you 3t squared minus, and then it's t cubed over 3, so the 3's cancel, so that just becomes t cubed, plus again, and some other constant, so I'll call that c2, plus a j. Okay, in order to find out those constants, we need to use the condition that we're given. So we're given the condition that when t is 0, r is equal to 6i plus 5j. So we need to substitute in t equals 0 into our expression. So when t is 0 in our expression, we get the fact that r is equal to, well, it's e to the 0, which makes 1, so this becomes minus 2 plus c1, lots of I, and then we get the 3t squared and the t cubed would both be 0, so this becomes c2 2 lots of j. Key thing we've got to be careful of here is the fact that the e to the minus 2t is not 0. And so that is telling us then that C1 would have to be equal to 8 to make negative 2 plus 8 equals 6i, and C2 will have to equal 5. And so our answer for our general displacement vector will be minus 2 e to the minus 2t plus 8, that's lots of I, plus, and then we've got 3t squared minus t cubed plus 5, lots of j. So where do we get our marks in this question? There's 5 marks to be had. So, initially realising that we have to integrate, we would get a method mark, and then we get 1 mark for each of these components being correct. For then determining the values of C in our expression, C1 and C2, we would get a method mark there, and then finally for having the correct solution we would get 1 mark. Well, hopefully you found that solution helpful. For further assistance with your maths revision, please go to the Further Maths Support Programme website.